quality of sound, noise, and superposition. So why does a trumpet sound different than a flute? The answer lies in overtones, which are sometimes called harmonics. Which ones are present? How strong are they? This makes a big difference. The plot below shows frequency spectra for a clarinet, a piano, and a violin. The differences in overtone strength are apparent. So we see relative amplitude versus various frequencies for each type of instrument. You note that this frequency within the clarinet is relatively strong, where another one slightly above 1000 Hertz is weak. The number of frequencies present and their relative intensity gives the clarinet its distinct voice. And it's obvious we can differentiate between a clarinet, a violin, and a piano. It's because of this concept timbre. The next slide will help us visualize why musical instruments sound different than they do, or have their unique voices. If you look at the standing waves in this guitar string, or these guitar strings, it's quite obvious that they're a mixture of standing waves, some low frequency, some high frequency. And their relative frequencies and or amplitudes give this their voice. So musical instruments have characteristic sounds due to the relative amounts of each harmonic present, or overtone. Notice that the guitar string contains many standing waves of a variety of frequencies. What we hear is the mixture of these frequencies, and it's called timbre. When problem solving and solving for the frequencies and or wavelengths that are associated with these tubes, first of all you have to note whether the tube is open or closed. Open tubes will resonate at F, 2F, 3F, 4F, and so on. Tubes with one closed end will resonate at F, 3F, 5F, 7F, and so on. One strategy involves determining the wavelengths. 2L for open tubes, 4L for closed tubes. Use the speed of sound to find the fundamental frequency, and then the harmonics are multiples of that fundamental frequency, again, which are going to vary depending on whether they're open or closed tubes. For closed tubes, they're odd multiples of F, and for open tubes, they occur at every whole number of F.